So yes, I will mention this for everyone here, just so that you know I'm recording. So hopefully you're okay with that. And if you miss any part of this workshop, we will be posting the link to it. So yeah. And with that, I will get started. So hello, everyone. We have a whopping 9 attendees, which is great. Thank you, everyone, for making it here. Hello, hello. And I will get started. So welcome. And so I will share my screen. So welcome to this workshop. Today, we're going to be deploying a web server using Google Cloud. Just as a kind of some administrative stuff, I only do have one screen, so I'm going to do my best to go back and forth to check if there's any people in the chat. So I just did, but do be patient with me if I don't immediately get back to you. It's because I don't see your question, but I will make an effort to check back in. Oh, welcome to the workshop. This is my very first workshop, so if things go a little not the best, then please be patient, for sure. Today we're going to be deploying a web server using Google Cloud. The emphasis of today is really on the basics. So just like learning the basics of like administering a Linux machine or Linux virtual machine. We do use Google Cloud, and Google Cloud has tons and tons of features. However, we're going to be focusing on a very small selection of those features, and specifically just virtual machines. So let's talk about the outcomes of today. Today, we're going to be deploying a Debian-based virtual machine on Google Cloud. Debian is like a flavor of Linux. So in Linux, there's lots of different flavors or distributions. Debian is a very popular one, and it's one that Google Cloud generally defaults to. So that's the one we're going to be using. We're going to be connecting to our virtual machine using SSH. So we'll talk a bit about what SSH is and why, kind of that process. Then we'll be navigating the command line. So in Linux, they provide this thing called bash. And bash, we call it is this shell language, et cetera, et cetera, et cetera. But it is generally speaking, it provides the command line interface, right, for Linux. We'll use bash to update and install packages, and this will all culminate in us installing a web server and browsing to it using our web browsers. The web server we're deploying, it's going to be not publicly available or accessible, but it'll be something you can access on your own machine. So we're going to be basically we'll be proxying the web server just to our machines, just to keep things simple. So the first thing I'm going to kind of launch us off with is talking about the Google Cloud CLI. So if you haven't done this already, and I'll take this link and post it in the chat, but if you haven't done so already, do take a look at this link and install the Google Cloud CLI. We'll be using it very briefly to do some stuff with, and it does take a bit of time to install. So originally I was going to install it with you all during the workshop, but it would take way too long. So do get started on that as we go along. The reason why we use the Google Cloud CLI is because we want a command line access to Google Cloud. So I will take a bit of a detour here and to just talk a bit about like how we can like manipulate and access Google Cloud. And what Google Cloud does is it provides multiple ways of like accessing it. And this is a standard across basically all cloud providers. So like Amazon has the AWS CLI, and I think even DigitalOcean might have something similar or something along those lines. And that's not even the only way, right? Of course, we have the website, like the Google Cloud website, which we'll use. And even further off, there's a thing called the REST API, which we won't use, but it's something that exists, and it's often used for like automation. So you can imagine like big businesses want to like automatically create like hundreds of virtual machines or whatever at once. They would use what we call the REST API. But that is way beyond the scope of this workshop. But I did want to just talk about it to give you all like a taste of kind of the big world of the cloud, which is ever expansive. As we before we kind of dig in, I'm going to just talk a bit about what virtual machines are and like kind of what the point of them are, because I think this can be a bit of a source of confusion. So virtual machines are like they're machines that are virtualized, right? So it's very straightforward, but you can think of it kind of in plain English as a computer inside another computer, right? So imagine I had my um, uh, uh, regular computer and I wanted to have like I wanted to launch a web server, for example, right? That's what we're doing in this workshop, right? Um, Installing a web server involves like having a lot of specialized software for that server. Um, and I don't want to run a web server all the time, nor do I want like a web server just hanging out on my laptop all the time. So virtualization lets us kind of have this specially built system that does kind of one specific task or just a few specific tasks, right? And in a virtual machine, everything is virtualized. So the CPU, right? It's not using I mean, it is using your host CPU, but to the virtual machine, it has its own like virtualized CPU. The same with networks, right? So a virtual machine could have like 100 different virtual Ethernet adapters on it, right? Or one, right? Like you could have, or zero, right? You could have as many or as little as you want. So that's kind of another benefit is that if say you want to have a lot of machines that have like a very complicated networking like topology or networking configuration, you can mimic that or replicate that with virtual machines. You can even virtualize USB. It's not often done, right? But it again is kind of just the principle, the idea of virtual machines. The benefits, I talked a bit about them, but the one main benefit is we get to really slim down our virtual machine, right? So the virtual machine we'll be creating today is going to only serve websites. And this might sound like not a big deal, but for organizations, this is such a helpful thing because now they can know what exactly their machines are used for. I had a prof last year talking about his time, I think at IBM, and he was talking about how they had this machine in the corner that did like 100 different things, and they didn't know what exactly that machine did, but they knew that they couldn't just unplug it because it's doing something important, right? So that's a bad situation, right? Because you have this computer there that you know you need, but you don't really know why you need it. Instead, instead of one machine doing 100 things, if you had 100 virtual machines doing one thing each, it might sound very inefficient, but now we can like be very sure of what's going on, right? Um, and imagine one of those machines fail or like software updates or whatever, you know, problems happen. Well, now the problem, we can be better sure to know what the problem is because chances are it's going to just affect one virtual machine, right? And not, just one big mega computer that, anything could be going wrong with. Um, Kind of along that note, virtual machines are really great for security. And we say it is because virtual machines have minimal interfaces. And this might sound very jargony, and it is, but um, when we talk about security, it's often helpful to talk about it in very broad terms, right? And broader than just like specific software versions or vulnerabilities, like broad in the sense of just knowing how could we possibly attack this system, and like what methods. So a great analogy would be like an apartment building. I live in an apartment with many other surrounding apartments, right? But we're all in one central building, right? So if you think about this apartment as a computer system, we would say that their interfaces would be like the doors and the windows, right? So that's how we get in and out. If someone was to break into the apartment, chances are they'll be going through a door or a window, right? They could go through a wall, but like chances are that's probably not very feasible for them to break down the wall, right? Computers, virtual machines are very similar, right? Because we have everything that um, because everything is virtualized. Virtual machines would have like their own share, right? So they would have their own files that aren't shared with other virtual machines, and they would have their own networks that aren't shared with other virtual machines either, right? So imagine a virtual machine becomes compromised. It gets infected with a virus, right? That virus can only peek at the files, the networks, or whatever of that virtual machine. It can't, it can't hop over to another virtual machine and mess around with files there. Um, and I say it can't, it probably wouldn't. But you can think with like virtual machines, like a lot of security focus when virtual machines is trying to prevent that hop, right? So we would say virtual machines have a lot of security benefits because their interfaces tends to be just like their virtual networks, right? It's not like, oh, I got a virus and that virus can see all my files and all my website files and like my other like service files, right? Whatever. It tends to be very contained, right? Like we would say like the attack impact is very minimized. Um, I'll just talk quickly about containers. So what about containers? You might have heard of this new technology, well, somewhat new technology called containers. And containers are newer. And yes, containers were created directly in response to virtual machines. And they're more efficient. Technically speaking, containers are more efficient because they share the kernel with the host operating system. The kernel is like the core of an operating system. Um, I'm going to give like a very unprecise description, but the kernel, like one of the big responsibilities of the kernel is to like interface with like physical devices and stuff, right? So say NVIDIA or AMD comes out with a new graphics card, they will write code for the Linux kernel so that the new graphics card can work with the kernel, right? So it's like a physical hardware item that the kernel knows how to deal with, right? And you might think with virtual machines, like we don't care, right? We don't care about physical hardware because it's a virtual machine. It's not ever dealing with virtual physical hardware, right? And so that's where containers come in. They say, well, if we're not ever having to, the host operating kernel, it already did all the work of interfacing with graphics cards and stuff. So containers will say, look, I don't need to do that whole process again with my own kernel. I'll just piggyback over the host operating system's kernel. That's like a bit of a very high level description. You can just think of it as containers are newer and they're generally better and more efficient because they share more resources with the host operating system. And since they share with the host operating system, it's like a lot of work that they wouldn't have to do themselves. They're often better, except containers are generally less secure, right? So remember I was talking a little bit before about interfaces and how like in my apartment, the door would be the interface that I would need to protect against. The more sharing you have, the less secure it is, right? So if there's a kernel like exploit or vulnerability, like all containers will like kind of share that vulnerability because it's sharing it with the host operating system. So it's kind of like the single kernel that all containers share becomes like an interface, right? It becomes an attack vector or a method of attack. So if one container becomes compromised, it can then go and say, oh, I'll just exploit this known vulnerability of the kernel. And then once I do that, it's basically game over. I can access all the other containers. This might sound a bit super high level or super like vague, but also technical. But you can think of it generally as containers are newer, they're generally more efficient, but this efficiency and this greatness, it comes at a cost, which is generally less security. Now, that said, Google and Amazon and everyone, they all run tons and tons of containers. If you heard of Kubernetes, Kubernetes was a way, like a method, like a program basically designed to run more and more containers. So obviously they have a lot of benefits and businesses really, really like them. So that security, not really a big concern for a lot of people. Another downside of containers is that we can't run different operating systems, right? This is because we're sharing this kernel, right? So when I run a Linux container, it's sharing the Linux kernel, right? And that's not the same as the Windows kernel. So if you wanted, if say my laptop is running Linux and I wanted to run Windows, I'm basically forced to use a virtual machine, right? And that's just because this, between Windows and Linux, it's not much to share, right? So containers are a bad fit for that case. I'm just going to take a quick peek and see if there's any questions. There's none, so that's good. If you do have questions, feel free to type them in the chat and I will get to them. But of course, at the end, you can ask questions then, or you can always you can ask questions outside of this workshop too, right? So don't feel pressured to think of questions during this workshop. I'll just end off with kind of a final point on virtual machines. So like Emil, you just talked about why containers are generally better. So why are we dealing with virtual machines? Well, there's a few benefits. They are easy to set up and to reset up. You can run virtual machines really, really easily on your own laptop. In fact, I have, and we're actually going to be using, I have like a decade-old computer that is stuck in a closet that's just running virtual machines, right? Because there's a lot of like hardware, like CPU support for virtual machines. So they still are a very popular thing. And the great thing about virtual machines is that you can mess them up and you can reset them up very easily. I spent my middle school like learning about Linux, and I did so just by, getting the USB key and installing it and then playing around. But then eventually I would mess things up, and I didn't know enough at the time to really fix my issue, or I would really destroy my system. And so then I had to deal with the whole process again, right? And on a like, I would not do that now as a college student because I need my laptop for assignments and things. So running virtual machines can be a great learning tool too. So that's why I like virtual machines. You also use a lot of similar skills. So containers are newer and they're better, but they are built on the shoulders of giants, right? They're built kind of as a continuation of virtual machines, as an improvement. So the skills you'll learn today will still apply to containers and kind of in a way to Kubernetes. Sometimes it can be overwhelming to think of all of these like different technologies that seem kind of like a bunch of disjointed things that you have to learn together. So I'm here to reassure you, it's a learning path, right? And just because you're spending an hour on virtual machines today doesn't mean that's like an hour not on containers. A lot of it applies. And then I'll end off like, yeah, you can run virtual machines very easily. I use VirtualBox a lot because it's very easy to use. So getting experience with virtual machines today will be great because you can really play around with them easily. So let's get started. Enough of me rambling. We're going to get started on Google Cloud to create our first virtual machine. And I'll paste this link in the chat. And if you don't follow along, again, this is going to be recorded. I'm going to show you a lot of helpful things at the end that will say if you're doing this, if you're just watching today and you want to do this later, I'll be showing a lot of resources that will kind of help you be fast when you're doing this on your own. So no worries about that. In the meantime, you will have to bear with me as I navigate Google Cloud. So this is my Google Cloud. You can see I'm on a project called Linux VM Workshop Failsafe in all caps. That we'll revisit that later, but that is just a backup I have. Instead, what you want to do is create a new project. And you can do that by going up top here. Your dashboard might look a little different if you don't have a project, but you want to find a page somewhat like this and then click New Project. What a project is in Google Cloud is kind of just like a very like abstract way of organizing certain resources together. So as a kind of preface, Google Cloud has all sorts of projects. They don't just do virtual machines. So they have like very specific products too, right? So you could have like a SQL server, right? Say you just want SQL. You don't need to worry about your own virtual machine and like setting that up for SQL. You could just say, hey, I want SQL. or I want a web server kind of thing, right? We're doing it in a virtual machine, but I'm going to guess you can probably just like request it, right? Like specifically for a website. Um, Now, when you think about like an organization, maybe they will want to or have some organization, right? So something like, the SQL server and this virtual machine are like part of one product, right? Like one web app, for example. And then we have like a separate VM and SQL server for a different web app, right? So projects can be a way to organize that. So I'm just going to call this Linux VM workshop. You can see I've done this before. Hopefully it goes well. And then I'm just going to hit create, and you can see it is creating. Google Cloud can take a while to do things, so be patient. And I say that just as it finishes. Um, while that thing is loading back up, um, I'm going to redirect us to this link, and I'm going to copy and paste it in the chat. So Google Cloud and AWS, I found out recently. So both Google and Amazon provide this thing called a free tier. And basically, they just give you some of their products for free. There's a bit of a caveat. You still have to put your credit card down to make an account with Google Cloud. So it really, and Google Cloud generally operates as like a pay-as-you-go model, right? However, if you follow all of these requirements, you should not be charged. Um, I know that's very vague. Uh, however, it is a great way to use it. I'll show you later. Kind of, they'll provide also some other cost estimates and stuff, so we can. I'll try to provide my best assurance that it should be free, like it should be completely free. However, in the rare case that we say misconfigure it or something, it should be less than $10 per month, right? And we're not even going to use it for a month, so 10 divided by 30, you do the math. Hopefully that's good. I know like getting charged for cloud services is not ideal for many students, me included. Um, but so I've done this quite a few times for this workshop specifically, and so I am like 99% sure that it will be costless for all of us. Now, in terms of what we need this type of VM in these regions and 30 gigs of the standard persistent disk. And these two are the kind of big requirements. We're not going to worry about snapshots and this is just kind of the how much data you can transmit out. We won't reach anywhere near 1 GB, so that should be good. So to create the virtual machine itself, you first have to be in the right project. So this is the project that I just created. So it's this one, right, the most recent one. And then what we want to do is create a virtual machine. So if you click the Create VM button, Google Cloud will take a while. And what you'll see is that I have to enable the Compute Engine API. So kind of just as a description, Google Cloud kind of gives you a project, but all of its features are disabled by default. So right, we were talking about the Google Cloud CLI. Imagine if I just like ran the CLI and just wanted to create a VM. If I use the CLI to do that without enabling this, Google Cloud will give you kind of an angry message, right? But you can think of that as like a helpful feature, right? So I won't be, if I have a project where I know I'm not going to use virtual machines and then I like accidentally mistype a command or something, Google Cloud should save me from my own mistakes, which is always helpful. So activating the Compute Engine API is going to take a while as well. So we will wait, and I'll see if there's any questions. There's none. So fantastic. On this topic, the next thing we'll be doing is installing VS Code. So you can type this into Google, but I'll also paste the link here. So yeah, we will be using Visual Studio Code. It's a little different from Visual Studio if you're familiar with that. I don't really like how the names are so similar, but VS Code is like an IDE. What we'll see is that it provides a lot of extra features that are helpful, even for someone like a systems administrator. So if one of the takeaways from this workshop is to use VS Code, that's great, right? It is an extremely helpful tool, and we'll be able to connect directly to our VM using it. So it'll be super, super helpful. Yay, just right on cue. It has um, done something. I'm just going to click back and great. This is Google Cloud failing, not me. Oh, wow. Of course, this happens when we run it live, but no worries. I do have a backup, but I have never encountered this issue before. So I do. Yay. Okay, we're back. And I want to click create VM, and it should take me to a different page than the first time. Another thing to know is this is a good reason why to use the CLI is because the CLI is less finicky than the web app. Cool. We have been brought to a page that is not full of errors. So we're going to be creating an instance. So an instance is like a virtual machine. They call it a VM instance. Not sure why they just changed the terms right now, but that's what they do. Call this, you can call it anything. If you can select it, I'm going to just refresh this page and hope for the best. Again, I do apologize. I do not know what's going on with the Google Cloud website. I am going to turn off my video, or not my video, but my camera, just in the hopes that you get the handy for the Google Cloud website itself. Oh, wow. Cool. We are back, hopefully, and I can click. Okay, I want to call my instance 1, and then now it's complaining. Can I just, okay, I'm going to call mine SD because that's all I can do. Hopefully those of you watching aren't having the same issue, but I am not sure if there's something wrong with my web browser or something, or what. Cool. Well, I can click other things. Okay, we're going to, hopefully that is just the extent of the issues. It's just on the name. So you can see that Google provides a helpful monthly estimate. You can see it's quite high. It's $25 a month. And that's because it pre-selects a E2 medium machine. We want an E2 micro machine, right? And we can confirm that with the description there. Maybe I shouldn't change tabs in case that makes an issue. Okay, so you can see it dropped down the monthly estimate. It's still $7 a month. However, if you go down, you can see this little helpful message to say that my free trial credit will be used for this. That's the main insurance I have that we're doing this correctly. Okay, so we have the machine set up, and the next thing we want to do is change the boot disk. You can see that the type, they pre-select new balanced persistent disk. However, we want a standard persistent disk. I think the balanced ones are just a bit faster, but we're not too concerned. So I do a standard persistent disk. It says we get 30 gigs, but I'm just going to set mine to 15. So 15 gigs should be enough fine. 10 gigs honestly should be fine, but I play on the edge. You can see the cost goes down even more. It still says I'm able to use my free trial credit, which is nice. And that's about it. The one thing I want to highlight with Google Cloud that I really like is you can get the equivalent command line or REST stuff. But for example, if I click this button, it gives me basically the complete command that I can just copy and paste into the Google Cloud CLI, and it'll kind of replicate all of these configurations, right? And this is kind of a bit of a foreshadowing. This is what we would describe something as like infrastructure as code, right? So this is more code than just clicking a bunch of buttons. And you can see why this might be useful because it's very repeatable, right? I can pass this off to anyone and they could run this. But making sure we're clicking the right settings, that's a little harder, right? And you can think about how prone to mistakes you might be, at least for me, right? I have classes and I have problems paying attention. So for me to always consistently do this, it's more challenging, right? Especially for organizations making like hundreds of these things. So I'm going to click create, and it is going to take a bit of a while to work. You can see the name is just SD because I could not enter in a better name. And you can see it's going to take a while. So this is one nice thing with Google Cloud is that basically they're like giving you a fresh Debian system. You can do this at home, like with like download Debian and put on a USB stick and then put it in your computer and stuff. But not only is this a lot faster, but it's a lot, it's a lot more automatic and a lot more consistent. Yay. Okay. So we have our VM instance. So we can begin to connect to it. I'm just going to go to the next slide and then show that for a second to talk just a bit about the steps. So right now we're going to connect with VS Code. So that's why we had you install it earlier. VS Code, if for those who don't know, is a text editor or IDE. The great thing about VS Code, it has tons of extensions. So Visual Studio is it's a very big program that's kind of all in one, kind of does lots of things for you. VS Code is kind of the opposite. It's very streamlined and it doesn't really do much out of the box, but it's very extensible. So it's kind of like there's a reason why Microsoft basically is putting the brakes on Visual Studio and has moved to VS Code, right? Because this approach of having a very extensible IDE is more or less the future. We're going to connect to it through a thing called SSH. And to do that, we're going to use Google Cloud to create what we would say is a SSH key pair, or basically it creates a mechanism for authentication, like a password. We're going to use the SSH extension in VS Code. We're going to update our SSH config, and then we're going to connect. Now, before we do all of those steps, I'm just going to talk quickly about what SSH is. SSH is this protocol that generally provides CLI remote login capabilities, plus general data transfer. But the remote login capabilities is kind of its big thing. You can think this is very, very helpful, especially now because we have a cloud virtual machine somewhere and we need to log into it. And it's not feasible for me to drive to Google, wherever Google is, and ask to log into it. So instead, we're going to use this SSH. It's authenticated via asymmetric encryption. If you have taken a class talking about that, good for you. I added that in just as a bit of a kind of like keyword in case you want to do some Googling later. But it's just a form of encryption for us as a high level. And the great thing, Google Cloud CLI handles this all for us. So if you were to set this, of course you can do this manually on your own Linux machine at home. But again, the cloud is nice because it's convenient. And the Google Cloud CLI will handle all of the configuration for us. And it will handle it in a very secure way. I'm just going to check if there's any questions. Yes, so Oscar, we do have to enable the Compute Engine API. So I'll just re-describe that. The recording will be on YouTube. However, it has not finished. We have not finished recording yet, so stay tuned in the Conestoga Discord for the YouTube link. But to get back to Oscar, yes, we have to enable the Compute Engine API. Google kind of, when we create a project, the project by default won't have anything enabled. So we'll have to enable. Basically, we were saying, hey, for this project, please enable virtual machines because that's what I want to do. So yes. And yes, as Gavin said, it should be available on our YouTube channel tomorrow. So thanks, Gavin, for that. I'm going to be going on to using or Google Cloud stuff. So here we have my very slow Windows machine. So I'm going to go to console.cloud.com, and we can see we are on the right project, and we're going to go to the compute engine instances, right? And we should see our SD, there we go, our SD VM instance. Now you might be tempted to just click this SSH button and be done with it. However, I am going to tell you to instead view the gcloud command. So we have the G thing, you'll just copy this. And then if you go here, we'll go to the Google Cloud SDK. Now, when you first open the SDK, it might ask you to log in because you haven't used it before. So that will just follow the instructions there. It'll kind of open your web browser to a thing, and you'll click, yes, I'll enable my Google, or I'll allow my Google account to be associated with this, and then it will redirect you back. But for me, since I already have that set up, I'm just going to copy and paste that command in. You can see I hit enter and I wait. And what it's doing is it's updating the project SSH metadata. So basically it's taking our like SSH key and it's kind of attaching it to the project. And afterwards, I can SSH to it. And so this is actually, if you can see this clearly, this is actually my Linux machine. However, I'm going to immediately just type in exit or click the X button because this text mode is a little inconvenient for us for what we want to do. However, we use the Google Cloud CLI because we still need to generate kind of the SSH key, but we're going to be using that SSH key in VS Code. So if you open up VS Code, it should look something like this. The first thing you want to do is install the SSH extension. I already have done that. But you would just go to the extensions on the left side and type in SSH. You should see this nice official Microsoft Remote SSH extension, and you just want to click install, which will be around there. Now, afterwards, we need to kind of update our, we have to update VS Code's configuration to be able to SSH to it. So after this installs, you will get this new tab for Remote Explorer. You can see I have my failsafe already configured, but yours will probably be empty. What you want to do is go to up here and then SSH and then click the little gear icon. And basically, it's going to ask us to select which SSH configuration file to update. Just pick the first one. The second one is kind of like a more general config, but you can just do the one for your user. And then you can see on your screen, you'll probably have kind of a similar looking thing, but it'll be more blank. In my case, I'm just going to copy and paste this. At home, you can just fill in the values. But for me, I want to have two things, one for the failsafe and one for the non-failsafe. We'll call this regular. Host name, that's like a DNS name or an IP address. So we just need to find the IP address, and we can get that here. So I can copy that and then paste it here. You're confused why there's two. This is an entirely different virtual machine. It's my failsafe. I'll actually switch back to it because things will be quite slow on the new one. But you will just have one, and that's okay. Under user, you want to fill in your username. So you can see here, I have the most boring username of just user, but yours might, on my another machine, it's Emil H, right? So whatever, if you don't have this open, you can just go up here and then click new terminal. And then whatever your username appears to be, that's what you want to fill up here. So at home, if I was to do this, I would say, okay, I'm just going to copy. Or, I mean, copying and pasting is kind of redundant, and I just mess things up. Okay. Don't mind me just utterly failing using VS Code. Okay, so I copy paste and put that down. Perfect. And then you just save. And you might think, oh gosh, it's not updating here. That's okay. Just click this little refresh button and you should see G Cloud Regular. Now here comes, I'm going to quickly check if there's questions. But there's none. I'm just going to click connect in current window. This one just connects it in a new window. And then the magic should happen. So the first thing I want to pick when it asks me for the platform, it's going to be Linux. So we are using Debian, and Debian is a type of Linux. And then it's going to say that it has this fingerprint. Basically, this is a way of authenticating, kind of making sure that I'm connecting to the right machine, right? You can imagine a very clever attack would be having a machine in between me and Google Cloud's VM. So ideally, you would want to check this. For the purposes of today's workshop, I'm not going to check this, but in the real life, I would. I'm just going to click continue. And now Google Cloud will, or VS Code will set things up. And it takes a while. And yay, hopefully everyone sees this. So you can see on the bottom left, that little SSH string is there. And if I open a new terminal, that is still messed up. Can I like, oh my gosh, yes. Cool. You can, so if I open the terminal, I'll move them back here. If I open the terminal, you can see that it's not PowerShell anymore, like it was before, right? It looks a little different, and it's not saying anything about a C drive or anything like that. This is actually like a Linux terminal. So if I do ls, right, that's a Linux command. If I did, if you know like command line stuff, you know that dir is a command, and that still works. Okay, I wasn't expecting that. But this is VS Code running in Windows, but it's connected to my Linux virtual machine. It's literally connected to that one, which is pretty cool. So if I did like uname guitar, this uname prints out the kernel version, right? So remember I was talking about kernels, right? And that's kind of a Linux. Well, generally you would say it's a Linux thing. You can see that it prints out the Linux kernel version. So yay, success. So I am going to go back. Can you go back to what you did after adding the info to the code? Yes. So if go back here and then I'm updating the configuration, I would save this. So I'll just pretend I modified it. So I'll save this, and then I will want to click refresh, and then your thing should be there, and then you can just click connect. That answer your question? It's still working. It is. I'm gonna, can I show just the identity file info again? Oh yes, so my apologies. So I'll actually paste this here. So this bottom part with the identity file, that will be the same across everyone in this workshop. Oh, my apologies, that's a good catch. So I actually have to type it in. It would be like dot type dot h slash Google Compute Engine. Cool. Sorry about that. Anyways, good catch, actually. I totally had missed that. Great. I'm going to just move on, but if there's any questions, please launch them in the chat. So I'm just going to talk a bit about what bash is. So if we if this command line like interface, that's actually bash, right? And bash is a CLI or a shell language for Linux. And I'm going to say something that many people on the internet are going to disagree with, but it's generally true. Bash is very much like a scripting language, like Python. Um, it's you can write scripts, right? It has this idea of variables. You can do like loops and if conditions and all sorts of stuff with it. So we call it a shell language, but mostly because Bash is so old that at the time we had mostly shell languages and we didn't really have this idea of scripting languages. But if Bash was to come out today, we might still call it a shell language, but we would be more willing to call it a scripting language. In Bash, we can run commands as with like PowerShell, or if you've done work on like Cisco devices and you've had the Cisco CLI, right? You can run commands, but in Bash, all commands are programs. So you can write your own your own programs. Just before we had the Google Cloud CLI, the Google Cloud CLI is just a program, and we run it like a command. Now, shell languages work from what we call a working directory. So if I go back here, and I'll type in this command, but don't worry about this. We'll cover this later. But we can see that it's saying this thing called /home. That's the working directory. So when we run commands, we kind of run it from a specific folder. So if you're saying running a command to copy a file, unless we provide like an absolute path or something, if you just say, hey, copy foobar.txt and copy it to a different folder, it will look for foobar.txt in for example in this /home folder. So that's kind of a bit about working directories. Moving on, I'm going to just do a bit of a quick start. So this is a very quick crash course in Bash, not Bath. Bash has a lot of different commands. There's this whole, you can probably read a whole book, or quite a few books on Bash. However, we don't have time for that. So we're just going to quickly run through some commands. The first command is echo, and that just prints a statement to a screen. So we can make our own hello world. So if I did echo hello world, it'll return back hello world. It's not the most useful command. However, you can think of why this would be a very useful command in a different context. Specifically, if you're writing scripts, echoes, many scripts that you'll find on the internet, they will have a lot of echoes in it, right? Because that's kind of like our cout in C++ or printf in C or whatever, right? That is echo. The next command is cd. So cd changes the directory, right? So it changes the working directory. So if I did, and you can see cd ... goes up one directory. So if I open up my computer and I went to a folder, say I'm on this folder, and I wanted to go up a directory in Linux, and also PowerShell, because PowerShell kind of copies a lot from Bash, I can just, so in Windows, I would just click this up button, but in Linux, I would run cd ... That would take me up a directory. On that note, ls lists the contents of the current directory. So I just went up to a directory. I need to figure out how to go back to that directory. So I did ls. You can see we have one folder called user. And if I did cd user, back to user folder. You might be wondering, this seems coincidental. Your username is called user, and you have a folder called user. It's exactly like the same idea here, right? So in Linux, we have this concept of a home folder, and the home folder will contain all of the users folders. In Windows, we have a very similar idea. We have a folder called users, and that will contain all of the users folders. Makes a bit more of a naming sense in Windows than it does in Linux. But yeah, that's the idea there. We do cat. So cat prints the contents of a file. So I don't have any files. So if I did ls, there's nothing there. However, if I did ls-a, you can see that there's a bit more files. So, well, ls just lists all it's like regular files. ls-a will show all files, including hidden files. So you can see we have like things like bash history and bash logout and bash rc. These are hidden, well, we call them hidden files, right? So the files that you will not like normally like interact with on a regular basis. So that's why they're hidden. Actually, in Linux, we a hidden file is just simply a file with a dot in front of it. So if you want to make any file hidden, you just give it a dot in front of it. But that's besides the point. What I do want to show is cat. So cat takes in a file name and it'll print out the contents. So if I did cat and then dot bash rc, that will print out the contents of this file. You can see a lot of kind of seemingly nonsense. This is actually a bash script. So pretty interesting thing there, right? But really, I just want to emphasize that the cat command prints out the contents of a file. And then the last command is man. So man shows the manual. So in Linux, generally speaking, most commands will have a corresponding manual. So if I did man echo, even something as simple as echo, which displays the lines of text, right? It has its own manual, and it's actually a surprisingly detailed one. And you can do things like, my favorite is you can make a bell sound with it, alert bell. So you can do a lot of weird things with echo, right? Another kind of just a trivia thing, but the man program has its own manual file. So if I did man, it's a very command. However, we can see that it gives us the manual page for the manual, for the system reference manual. So as you're, and you can see I can actually scroll up and down with my mouse, but you can also do that with the keyboard arrows. And the helpful thing here is when you want to exit this, you type Q to quit. So that's the main, most important thing. There is just the manual. As I was starting out with Linux, I kind of hated using the manual. However, in my somewhat accumulated wisdom of using Linux, I do recommend using the manual, even though it's kind of archaic and sometimes hard to understand, but it is also, it generally is very comprehensive, which sometimes like Stack Overflow is not as comprehensive. I mentioned earlier that Bash has this idea of variables, and it still does. However, it also has this idea of like special variables. And the one I want to highlight is PWD, and that's the current working directory. So the first thing is all variables have this $sign in front of it. That's like between, if I did echo PWD, it would just be PWD. However, if I did echo $PWD, it now gives me the actual variable PWD. So if you have programming experience, this makes a lot of sense. But if you don't, the main thing is when you want to find out the current working directory, just do echo $. That's that. So we have this kind of quick start of Bash. The next thing, and I apologize for the heavy explanations, but the next thing I do need to cover is a brief primer on Linux security. This is super quick because partly it's very simple. So in the last slide, I was talking about how, or in the previous slides, I was just talking about how in Bash, everything is basically like a program. And in Linux, that's kind of a recurring trait. Everything is generally just a program, including Linux's approach to security. So on the very high level, Linux will come, like all Linux distributions will come with the single user called root, and it is the supreme user of the land. Root can do anything. Um, and there, I was going to say barring some sensitive things, but no. Uh, in Linux, the root user could try to destroy the whole operating system, and Linux will just, if you were root and you try to destroy the whole like operating system, Linux will try until it's too broken to continue functioning, right? So as the root user, it's very important that we're careful what commands we run. And generally speaking, we don't want to be root very often, right? Because it's, great power comes great responsibility kind of situation. And it's way too much power than we often need. Um, so we often, so when we want to give other users, like my user, um, root level privileges, Linux uses a program to do so, and it uses this program called sudo. So basically, the nutshell is we want to run something that's privileged, you will want to run sudo before the command. So as a quick example, and this is going to be a very silly example, I could do echo. Oops, I could do echo hello world, and it will just print off hello world. I could do sudo echo hello world, and it does the same thing because it's just printing out, prints a line of text was what the manual said. But in this one specific context, it was running this echo as root. You will see more sophisticated examples later. The great thing about sudo is that since it's a program, it's very configurable. In Google Cloud, this is all pre-configured for us. So in a normal Linux situation, we would have to add ourselves to this to be a sudo capable user, and that is kind of a whole process in its own. So the great thing about using Google Cloud is that when we use the Google Cloud CLI, it was like, oh, you're creating a new user to connect. Like, we're just going to give you sudo privileges as a convenience. So you don't even need to worry about how you would configure sudo. Google Cloud is there to do everything for you. Okay, I'm going to quickly branch off to check for questions. Yes, that's a great observation, Quan. Hopefully I'm saying that right. But yes, when we're talking about rooting your Android phone is basically running Linux. And so when we say, my phone, which I have not rooted, oops, my phone, which I have not rooted, I don't have the root account privileges, and basically like Samsung or Google, whoever would disable that. So when we root our phone, we're basically often using an exploit to get access to the root account. And since we're the root account of our phone now, we can do whatever we want. So yeah, you're exactly right. That's a very good observation. I unshared my screen just to a tangent, and that was not a good idea. Okay, so now that we have an understanding of roots and a great observation about rooting our phones, we're going to talk about updating and upgrading. They can be different processes. So in Linux, we use these things called package managers to install software. Just as we talked about like bash commands and sudo, our package managers are just programs. And kind of beyond this, there are in newer ways in recent times, we've found newer ways to install software, but our package managers still remain a very popular way to install software. In Debian-based distributions, so we're running Debian, but so this is directly applicable to us, we use the program called apt, APT. But you might also have heard of Red Hat Linux or Fedora or CentOS or something like that. Those are all under the Red Hat umbrella. Red Hat is a company. And so the Red Hat side of things, it uses a thing called DNF. Now, this begs the question, which is better? But they're basically the same. Maybe at a different point in time, we might have a heated argument about which is better. But in recent times, the features are about the same. They do about the same thing. So we're not too concerned. And kind of beyond the scope of this workshop, but there are tools that will you can write kind of one set of instructions and it will figure out whether to use apt or DNF and do the stuff. However, for today, we're just going to be using apt. So to update and upgrade our Debian Linux, so I said this was kind of a different thing. So why do I make this distinction between updating and upgrading? Well, the apt program, it keeps track of what possible software exists to install, right? So we call it a package list. So in your package list, it might say, hey, like, this Firefox is of version X.Y.Z. And it just, it's like a local cache um, because there are a lot of software out there. And so for apt to, you know, for efficiency's sake, it keeps kind of a local copy just to not have to download a bunch of files, like package files, every time we want to see what's available. So the first command we want to run is sudo apt update. So hopefully this command makes sense. We need to use sudo because it turns out installing software is a privileged command, so we can't just run it normally. I can demonstrate this. If I just try to run apt update, it's going to complain, and it's a lot of permission denied. However, if I ran sudo apt update, and all those complaints disappear. So that's why we need to use sudo. You can see after I ran sudo apt update, it says that 7 packages can be upgraded. So you notice here, it's not that they have been upgraded, but they can be updated. And that's because, again, we have updated our kind of local list of possible software, but we haven't done anything with it yet. That's where sudo apt upgrade comes. That actually performs the upgrade. So I can just run that here. And it's going to ask if this is okay. And I'm going to hit Y, and it's going to do its magic and actually upgrade. And you notice that this process is actually a bit longer to do. Now, at this point of the workshop, you might face the issue that I am facing, which is that the virtual machine can kind of hang up or slow down every once in a while. If this continues, I will switch to my handy dandy little, I'm gonna close that, my handy dandy little fail-safe virtual machine. But we will keep going for now and so we've updated and we're in the process of upgrading. Now we can get ready to run the web server itself. Now we're going to do so via this program called Apache 2. So first thing to know, Apache 2 is just a program, right? It's not like an inherent built-in thing of Linux or the Linux kernel or anything like that. It's just a program. And there are many ways to run websites. Apache 2 is just one of them. It's a pretty old, but it's still an incredibly popular website server program. You might have tried to browse a website and you get like a weird error and it will say something like Apache something something something. Yeah, the Apache 2 kind of, if not still, it definitely used to be the backbone of the internet. And Apache 2 is very powerful. We can serve dynamic and static websites. However, today we'll just be serving a static one. But yeah, it's the configuration of Apache 2 is kind of way beyond the scope of this workshop, but or the full configuration of Apache 2. But we will be doing some basics with it. So this brings us to more commands. And I'll just check if questions. Can I do all of this via VM software with the Linux VM? Yes, of course. You can definitely do this with VM software. I chose to use Google Cloud kind of as like a fun, like, oh, where it's Google related sort of thing. And because it's a good introduction to Google Cloud, but you can definitely do this with any VM software. VirtualBox is a good one. In Linux, there's actually like a whole slew of them. But yeah, like Hyper-V Manager or whatever is in Windows, it's a good option as well. So yeah. So I'm going to be going through some more commands. So we need to be installing Apache 2. Now, the command for that is very straightforward. sudo apt install Apache 2. So sudo, again, because we need root privileges, apt is our package manager. We're going to install Apache 2. That goes without saying. So we can see here that this this virtual machine is kind of hanging up. So I'm going to switch to my trusty other one and run the command there. The reason why this virtual machine will be faster is because it has a lot of the packages kind of pre-saved. So when I run sudo apt apache 2, it should be a pretty fast command. And it is installing 80%. Yay, it worked. Okay, so since I'm using my own a pre-configured virtual machine, I might get a little ahead of the workshop. I will do my best to try to keep this one in line, but as you can see, it's taking a bit of a nap. So I will switch to this one. And so for those of you watching, if you want to kind of pause, if your virtual machine is also acting a little slow, you can pause and just watch me and then follow along later. And spoiler alert, I will provide some like really fast ways of doing this that you can learn from. So don't worry about like memorizing each specific command kind of thing. After we install Apache 2, we want to enable and start it. So this is a bit beyond the scope of the workshop, but in Linux, we have this thing called systemd. Systemd is like the sheriff of, or I don't want to use poor analogies, but systemd kind of manages things like services, and our website is going to be like a service. So a service would be like a long running program, right? So imagine like a website is a classic example of a service because it just runs all the time and waits for connections. So we want to enable it and then start it. So enabling means just to instruct the operating system to start it at boot. But since we already started, like since our virtual machine is already booted, this won't actually do anything immediately. We would have to restart the whole virtual machine. That's going to take way too long. So we can just directly start it using system control start Apache 2. I'll run both commands just for correctness. But the first one I'll run is sudo system control enable Apache 2. And sudo system control start Apache 2. And nothing happened. But the web server, I promise, is running, and we will see it. This is not the end of the workshop. So let's browse to our website. So via a port proxy over SSH, we'll be able to access our website. So you can imagine that the method of getting our website accessible to the public web, it's a little bit more complicated and a little bit more expensive. We would need to get a domain or something, or figure out complex firewall rules, right? We would have to look more with Google Cloud. That's beyond the scope of this workshop. So instead, we're going to be using VS Code to proxy our website. So basically, what VS Code is going to do, it's going to instruct the operating system to send our website over the SSH connection. And we can do so via the ports tab. So if you remember our website, uh, I guess if you remember how websites work, we'll remember that websites or like the HTTP protocol by default runs on port 80. This is not like a technically strict requirement. You could have websites on any sort of port. However, the standard, like the convention is port 80. So if I type in port 80 here, this will take port 80 of our virtual machine and mimic it, like mirror it on our local machine. So basically port 80 of the virtual machine becomes port 80 of our own machine, right? So if I click this button, wow, that is the Apache 2 Debian default page. You can see I'm running Windows, right? I'm not running Debian. And it says it works. That's very reassuring for me as running this workshop. But you can see that we're connected to localhost, so we're connected to this machine, but this machine's port has become the virtual machine's port, if that makes sense, right? Like the virtual machine is sending the website like through our direct connection, um, through our direct connection to be accessible here. Um, so I'll check to see if there's any questions. And it's none, but that's the we're not done with the workshop yet, but that's like the big hurdle, like the big achievement, is getting to see our website. Now it is not publicly available. So for example, if some regular person on the internet tries to connect, they would have no method of connecting to my own website, which can be a downside. But I think for students, this port forwarding can be very, very helpful, right? So imagine I'm working on a website um, or something, and I'm like not ready for it to be publicly available. Port forwarding through VS Code can be a real lifesaver for me in terms of testing or anything like that. Now, just this one static website page is kind of boring. So let's launch like a real website, quote unquote. Um, I have and I need to correct this link, but um, I have a GitHub repository, and I will get it up here. I have a GitHub repository, and in this GitHub repository, I have this little website, right? You can see an index.html and blah, 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 right? This is just a website. It's a static website that I launched just for my own personal stuff, but it's great because I can use it for this workshop as well. So I will copy the link into the chat. And we can take the files in this website and launch it. So um, kind of as an aside, I made this website through this thing called Jekyll. I'm not going to talk too much about it, but it's basically like a website generator for you. So I can write very simple blog posts that aren't HTML, and Jekyll will make them HTML for me. I just included this here because I know personal websites tend to be a popular topic, including for myself. So Jekyll is the thing to Google to learn more about that. So this comes the real tricky part. There's a lot of commands, and I'll run through them quickly, but we'll see a much easier way to do all of this later. So we're going to be retrieving and copying our website. The first thing we're going to be doing is do cd and then this little squiggly slash. This just makes sure we're at our home directory. So that slash, that squiggly slash is just a convention. But that command is not as important. The next command we'll run is git clone and then this huge URL. If you've used git anymore, if you used git at any time before, you will recognize this command, right? This is just a typical git command to clone our stuff. Then we'll use cd to go into that directory. So when we run git clone, it'll clone our repository to this folder, and this folder will be called this GDSC deploy web server workshop. So we'll need to go into that thing. Then we can run this command. So sudo a2 this site disables and then with 000-default.conf. If you remember over here, this is the default site. So we want to disable this default site first before adding our website into it. And we can use system control to restart Apache 2. So basically, when we disable the site, we'll need to reload Apache 2 to reflect those changes. And then we can, this is very complicated, but I promise there's a light at the end of this tunnel, right? This is why I'm laughing, not because of this terribleness. So we'll do sudo rm-rf/var/www/html. So this will destroy the old website folder, and then we're going to actually recreate this whole website folder So basically, we just want to make sure this website folder is empty, right? And we do so by deleting the whole folder and then creating it. And I'm going to gloss over these commands. The link for the slides will be available as well. But uh, yeah, I just for brevity, I'm just gonna gloss over them. And then the last final thing is to copy our website over. So we're gonna be copying the contents of my website to this var www.html folder, and Apache 2 will know this is kind of like a standard for where to put HTML files. So Apache 2 will know to serve things from that. So I know that's a lot of talking. Let's kind of dig into that. Um, so let's get started. And I promise there's a light at the end of this tunnel that's a lot more convenient. So the first thing we want to do is do cd squiggly slash. Actually, see if I can zoom in a bit to make it a bit more readable. If I run ls, I'll actually see that I'm in, I already have that folder. So I'm going to skip the git clone, but I will copy it to the, oh, that extra, next slide. But I will copy it to the, uh, oh, thank you, Gavin. Gavin came in with the clutch. Okay, yes, so Gavin has copied all of the commands there for you because he is a lot more thoughtful than I am. So follow along there, and I will type them in as well. Except that I'm skipping this git clone stuff because I already have it. Okay, so make sure you run git clone because, and don't ignore me when I don't have it. Ignore me because I already have it. The next thing I want to do, pretending that I already ran git clone, is run cd gdsc dash deploy. Now, if I hit tab, so you can see I have cd gdsc dash deploy, and if I hit tab, it autofills. So do that. The tab is kind of like an autofill thing. So if I'm running, like if I do cd and then if I did cd here and a bunch of tabs, it actually will just like list all of the things that are in my folder. Now, one thing I noticed kind of recently is that Visual Studio might say, hey, do you want to install this extension for this thing called dev containers? You can just ignore that. So yeah, any warnings from VS Code, just ignore for now. Now, now that I'm in my, so I've ran this command, so I've opened my directory basically. Next thing I want to do is a to this site. So, and I want to run that with sudo. So it's sudo a to this site 000 dash default.conf. Okay, it's disabled. So now I just need to run, and it's telling me kind of what to do. So that's helpful. So I run sudo system control reload Apache 2. And then the next thing is to rmrf, make the dir, and then copy all the things over. So I'll run that. So sudo rm-rf slash var slash www/html, and sudo make dir slash var slash www/html. Last command is copying. Copy href. And I'm sorry that it's a bit cut off, but I'm just copying the contents of the website over. So sudo rf my website. Oops, my website star. Now, why do I have a star? The star we refer to as like a, it's called a glob, but it's kind of like a catch-all. So basically it's saying, we have this folder called my website. Like copy everything in the website. Like don't copy the folder itself, just the contents. That's var www html. Okay. So what just happened? However, if I open my website, You can see it's a totally different thing, right? It's totally different from this one. And actually, if I refresh this one, it'll change too. Right, so this is like my personal website. Yay! Um, uh, and you can see I can click links and stuff, right? So Apache 2 is completely like usable as like a website server, right? And many people use it. Um, so that is kind of like the culmination. Hopefully, that's pretty exciting, um, because it is. However, what was not exciting is all of these commands. And I'm just gonna, this is kind of the end of the workshop. However, I'm gonna just give a bit of a preview. It's a famous quote from Federico Garcia Lorca. This is a quote I stole from a Google book, so that's why I'm sharing it. But it's talking about how besides Blackheart, there's only automation and mechanization. And automation is kind of the big thing today. So I just wanted to kind of give a preview of why automation is good. You could probably guess because running all of these commands is a real nuts. And even if you wrote all of those commands down, which I did, like if I was to do this 100 times, I would make a mistake, right? Like I would mess up something somewhere, right? And this is not even the most, complex things, in a real company, whatever. They're probably doing even more complicated things that I have no idea how to do. So that's where automation comes in. And there's a few forms, and I'll just like showcase some of them. The one form is as a script, right? So remember how I talked about um, how Bash can be used to create scripts? It still can. So if I go to File and then Open Folder, I can actually open the repo folder. So I already have it open, but I'm just going to reopen it. So if I click OK, it's probably not going to do anything because I'm already in the folder. But you can see that I have these files that end with .sh. And I have one that's called startwebsite.sh and one that's called stopwebsite.sh. So how do we run a script? Well, the way we do it is just by typing it in. So if I type in sto and then tab it, I might have to do /. So actually, to run a script that's in your folder, so if I run ls, that will list all of the things in my folder. You can see I have this green file called stop website. Now to run the script from my current folder, I will do // and then stop and then website, blah, blah, blah. But I can just hit tab to autocomplete. So to run that specifically, it's / and // I think. But I always confuse my forwards and backslashes. But the slash that's near your shift key is the slash you want to use. And let's see what happens when I run that. So you can see it's doing a bunch of things. Some of the things kind of look familiar to doing it before. And then you can see it ends with done. If I look at the bottom of the script, that's where echo becomes super useful. And then if I try to open my website, it might still initially work because your website will often like cache things. So even say you try to connect to Google and you don't have a internet connection for like a split second, your web browser might just serve you Google anyways based on like a local copy. But you can see here that actually nothing's working, right? So it's not even trying to use the cache, right? And that's because my one single script um, uh, did everything for me and deleted everything and stopped Apache 2, right? And if you look, we can see things that maybe we recognize, right? Like we see some apps and remove, right? So it's probably removing something, that kind of stuff. On the flip side, if I run startwebsite.sh, you can see it's just doing a bunch of stuff. And we wait and we wait. And you can see if I open this port website again, you can see my website's back, right? So all those commands that we slogged through and that Gavin had to copy over, right? Meaningless because we have a single script that can do everything. And all of these scripts are found in the GDSC deploy workshop folder. The last thing I'll just show off, hopefully, is Ansible. So the first script I'm going to run is /Ansible. So Ansible is a program. And what makes Ansible really great is that it's basically like bash scripts that you can, like bash scripts that are supercharged. So the first thing is, uh, Ansible uses this file format called YAML. I won't talk too much about it, but it uses this one file to kind of like a script, um, but it does all of the same things. However, at the very, very top, you can see that there's a section called hosts. And right now I have it set to localhost. So it's only going to work on this one machine. But imagine I had like 5 computers and I all wanted them to serve the same website or something. I could do like something like server 1 and server 2, etc., right? And that's the power of Ansible, is that you can really automate tasks across a whole slew of machines. And Ansible is not the only way to do it. It's the way I'm familiar with. But these tools like Ansible, Terraform is a related tool, right, which is similar. There's also things like, I think, Puppet and Chef or whatever. There's a lot of buzzwordy names in this space and the reason is because there's a reason, right? Like even if you look at the scripts, right, the scripts output, not very helpful, right? Because it's just the command output. But if I ran Ansible dash playbook and then my playbook.yaml, right? This is the name of this file. The first thing you notice is I made this huge comment thing, so we can set the state to stopped or started. So stopped would mean that the web server stopped, and started is the opposite. So right now, what this playbook is going to do is stop my website, right? So it's running currently, but if I run this, you can see it's running. The first thing you can notice is that the output super clear, right? We can see like individual tasks. We can see I can change the names of what these tasks are, so they're very readable. And then if I go over here, we're back to just waiting for a dead website to come, right? And it will never come because the website stopped. On the flip side, imagine I just changed this one word to started and I ran it. See, it's kind of having the same steps. Install and uninstall will take a little bit longer, right? But it's doing the same thing, but now in reverse. And now if I go to my website, I just wait for a bit and then hope for the best. The website should come back, presumably. Oh, this would be so awkward if it didn't work. Okay. Another great thing about Ansible that I will just briefly share is that you can easily rerun playbooks over and over again. Well, this is awkward. Oh, there we go. Thank goodness. I was about to just give up. So yeah, you can see that Ansible, of course, Google Cloud's sometimes a little bit slower to pick up with things, but you can see that because of Ansible, I can just easily start a website. And the last thing I'll end off with is that the really helpful thing about Ansible is that this stuff is all, and like it's very human readable, right? More so than bash scripts, right? So you can see that I have a couple of like I'm installing Apache. I also need to install this rsync package, but that's kind of unrelated. But you can see that I'm just listing exactly what packages, like what software do I need, and I can, I can give like this name, I can give it to whatever. I can call this foobar 101, right? Or whatever, right? So Ansible has a lot of mechanisms to help keep things readable. So that's enough of rambling about Ansible. I'm going to check if there's any questions, and there's not. Good. But yeah, what I wanted to end off with is not, oh, everyone should use Ansible or everyone should use bash scripts. It's just to say, sometimes when we're using computers, things can be very difficult and very time consuming, like all of these commands. And so, what I would suggest kind of, and this is just my opinion about learning in general, what I would suggest is, don't spend like an incredible amount of time like learning bash scripts or even learning Ansible, but instead try to like um, find easier ways of doing things, right? If you're coming across like a process and it's just taking forever and you have to keep doing it over and over again, right? In my class, we had to set up SonarCube, and then we had to set up SonarCube again for a different class, right? A ripe target for automation, right? Because if I can do it once, I can do it repeatedly. Um, right? With these scripts that I've shown, with this Ansible stuff, and even with these Bash scripts, right? I could run them over and over and over again, and they will work, right? And even if they, like sometimes maybe there's an update to Linux or something, and then the scripts don't work as well, they stop working, that's still okay because and this is just my experience, but that's still okay because generally when the script doesn't work because of an update, the fixes are small, um, and um, and easier to detect, right? Because, for example, with this Ansible stuff, you can see that like some of the tasks report okay, or some of the tasks report changed, right? If it failed, right, it would say failed instead. And so I can note like, hey, exactly which task did we fail, right? It's not like, oh my gosh, I tried running through these steps of procedures and it stopped working, but I'm not even sure where it stopped working, right? Because I had to read all of these, like, if you were just running the commands like as a bash script, right? Like, where are you going to find out? Like, how are you going to know what failed, right? That kind of thing. So sometimes it can be like overwhelming to see all of these like new things like Ansible, whatever. And I don't mean to like scare anyone for sure. I want to like say this is the light, right? Like this is the new way of doing things, because in the end it becomes a lot easier. And for me, in my experience, like I do not know much Bash. I'll be straight up and admit that, but I never need to learn much of it because I've had Ansible instead. So I'm just going to end with some conclusions and next steps, and then we'll be wrapping up with feedback form and raffle. So get ready for that. So what did we do? We created virtual machine on Google Cloud. That's really amazing, right? I've only been using virtual machines on Google Cloud for less than a month. So I still think it's, I don't know, I think it's the most coolest thing to have this free virtual machine on the internet. And we've navigated the command line, right? We used Bash to install a web server. Specifically, we installed Apache 2. And of course, Apache 2 is not the only kind of web server, but you kind of know the process now of how you would install software and run software, right? If there's another web server called Web Server 2000, we would still install it through apt, we would still enable it through systemd, and you'll still start it through system control. And we would still like view the like local proxy copy through VS Code, right? So the process still ends up being very similar. And then we viewed a website through a proxy provided by VS Code. So at the end of this workshop, you might be wondering, what should I do next? And there's a lot of things, or a few big things, I would say. The next thing is you can explore using virtual machines on your own laptop. I think one person had mentioned that and asked if it's similar. Absolutely. I will give a shout out to VirtualBox because I think it's easy, but I'm not in any way affiliated with that. In Windows, there's also a thing called Hyper-V that's like kind of built into Windows, I believe, or something. So exploring virtual machines on your own laptop is great, especially because there is no way you'll incur a monthly charge, right? Like you don't need to put in your credit card to use VirtualBox. The next thing is that you can try doing is exploring Linux. Linux is a kind of a huge topic, but like an introductory like LinkedIn course or YouTube course or even a book can be very helpful. I kind of talked about like very different parts of it, right? Like the security ideas behind it and like, upgrading, managing packages. It can be very hard to like keep track of all of those different topics. So I do suggest something like a course, and it doesn't need to be like hundreds of hours. Like I don't know, I've seen those YouTube courses that are like 30 hours long. You don't need to do that, but getting comfortable with navigating the command line, for example, and basics things, and like understanding, I guess, maybe more of the theoretical aspects, like why do we use sudo, right? Like what's the point of sudo and that kind of stuff. Very, very helpful. And it's especially today, right, when we have containers and like Kubernetes and all of this cloud stuff, it's built on the backbone of Linux. So Linux becomes like a very useful skill in a increasing number of areas. So I'm a bit of a Linux fan, I guess. So maybe other people have different opinions, but Kubernetes is becoming a very popular thing. And so I think because of that, it gives credibility to what I'm saying here. The last thing is to learn more about automation. I am a big, I'm obviously a student in this, and I'm honestly a very much a rookie in terms of automation. But hopefully we saw that it is a lot more convenient to automate something than to memorize this slew of commands. Especially, I would say, as we're learning, right? So if we're learning Linux, if you write scripts, even if there's bash scripts, if you write those bash scripts as you're learning, those bash scripts become a resource, right? And this is why I think why I really want to share this repo, and it's great that Gavin bailed me out and I typed, showed the commands as we went along, because this kind of, we in software we might say this is like self-documenting code or blah blah blah, which is buzzwordy, but in plain English, like it's very helpful to have the script with all of these echoes, because we know exactly what we're doing. And memorizing a slew of commands, you might know it for a few days, but then I am quickly forgetful. So um, uh, writing things down, automation, I kind of would describe as just writing things down in a scriptable way. So very, very helpful, and I hope I kind of impress that upon all of you. So with that, that is the end of my presentation. We're going to take a quick break for questions and that kind of stuff. So if you have any questions or you want to take a water break or whatever, go for it. Otherwise, I will copy and paste the link to the feedback survey. We'll take a bit, like a 10-minute or 5-minute break for people to fill them out, and then we could have a raffle.
Yeah, actually, I was thinking we could just give everybody who fills up the survey a
Oh,
shirt. Yeah.
yes. So I will first step. Well, actually, I put a link in the. So no raffle, but everyone gets a shirt.
Yeah.
But please,
You just got to fill
in.
out the feedback form. That's all.
Yes, the feedback form is what's required. And it's very short. I only made it like 5 questions. So don't think that you're signing up for this whole extensive research thing. But yeah, I hope this is my first workshop. So if there were places that could be improved, please fill them out, because I am definitely still learning kind of the best way to deliver stuff. So your feedback will be incredibly valuable for me.
Awesome. Yeah. And then with the feedback form, when you fill it out, I will probably maybe email you or something, and probably hand it out sometime next week. Hopefully our schedules match or something, or like I can be at the Waterloo campus and pass that stuff out.
Mm-hmm.
Awesome. Well,
Yay.
with that being said, yeah, I hope you guys have a good night.
Yes. Yeah, and after this workshop, if you have any questions, like maybe my code isn't working or something like that, I am definitely available on the Discord for the Conestoga GDSC group, so you can reach me out there. And yeah, I do hope to plan workshops to kind of build upon. I know this workshop is kind of very basic on Linux stuff, so later workshops I'm hoping to build upon it. So stay tuned.
Awesome. Okay. Thank you,
Awesome.
everybody. Enjoy your
Bye.
night. Bye.
Stay warm. Bye. Okay, and I will click stop recording.